Okay, in geometry, they're going to talk about inductive and deductive reasoning. Today, in the start of this chapter, we're going to look at inductive reasoning and what they call conjecture. First, the author talks about the inductive reasoning. That is reasoning that uses a number of specific examples to arrive at a conclusion. Reasoning that uses a number of specific examples to arrive at a conclusion. Okay, and I'm going to go through some examples here in a minute. Okay, but that's how this author defines inductive reasoning. Okay, then the author talks about conjecture, and I'm guessing for probably both of these are probably new terms to you. Okay, conjecture. Okay, conjecture is an educated guess based on known, an educated guess based on known information using inductive reasoning. So you're going to look at the specific examples that they give you and then try to base your conclusion on that. Okay? Now, I'm going to go through two examples for problems like you might have in the book. Okay? One, say the directions say make a conjecture about the next number Okay, make a conjecture about the next number based on the pattern. Okay, now some of these will go pretty quickly because you can see a pattern. But some of you might have to do a little bit of trial and error. Okay, on the first one, let's say the author gives you the pattern 2, 4, 12, 48, 240, okay? And they want you to make your conjecture what that number is based on the pattern they're showing you. Any ideas? What is it? So, are they adding, multiplying? Multiplying. So like 2 times 2 would be 4. 4 times 3 would be 12. 12 times 4. So they're doing 48 times 5. So we need to take 240 times 6. So 240 times 6. You agree with that? So 1,440. That would be our conjecture. Okay. Our guess based on that pattern. Okay. Is 1,140. Okay. Does everybody see the pattern? Okay. Now that one came pretty readily. Another type of problem. Okay. For the points L. Remember, for points you're using uppercase letters. For points L, M, and N. LM equals 20. Mn equals 6 and Ln equals 14. Okay, it says for points L, M, and N, Lm equals 20, Mn equals 6, Ln equals 14. And the directions say, make a conjecture and draw a figure to illustrate betweenness. And we already did betweenness in the last chapter. Okay? So, I would do the picture first. Okay? What are the two endpoints? L and M or N? Like this? Okay. And then N is somewhere in between. Okay, and if you look at our picture, Mn is smaller. If you look at this, Mn, so let's go like this. Okay, so if we said Mn is 6, Ln is 14, Lm is the whole thing. Whoops, I didn't draw that very good, sorry. This whole thing is 20, right? Okay, now they make a conjecture and draw a figure. Well, we've already drawn the picture. Now it's your conjecture. Your conjecture is, for betweenness, it's always this part plus this part equals the whole thing. So it's basically state the betweenness property. So Ln plus Nm, okay, equals the whole thing, Lm. Could I turn these around and say NL? Yeah. I can turn those around. That's it. Okay. Now here's one other conjecture. This would be one. Somebody may have said, okay, this is my educated guess. It's the betweenness property. Here's another educated guess. Okay, another conjecture possible would be to say L, M, and N are collinear. Isn't that true? They would have to be on the line. Yes. Okay. So now, the assignment is to read that section. Does that mean you close your iPads and do nothing for the next 10 minutes? No. Okay, I'm not giving you a written assignment. I actually want you to look at the book. It's section 2.1. On your iPad, everybody know how to get to the